solution, infinite solution equations. So we'll start with the no solution equation first. So I'm going to go ahead and simplify this. Make sure that you distribute the -4 to both terms inside the parentheses. And then when you gather like terms, if I add 8x to both sides, then what remains is -4 equaling -2. Notice that positive and negative 8x right here are additive inverses, and they sum to 0. What remains are two numbers that are not equal to each other. So this is a false statement. When the variables sum out of the problem and the two numbers that remain do not equal each other, that is a false statement, a false outcome. And this is a situation where you would say that you have no solution. The 0 with the slash through it represents the null set, which is the set with no members, the null set, or the empty set. So it's important for you to be able to recognize when this happens, and it's important for you to be able to go on and claim the result. So you can say the words no solution, you could give the symbol for the empty set, and I think that would be sufficient right there. But you need to let me know in some way that you realize that this equation has no solution, meaning that there is no x value. If I go back to the beginning, there is no x value that is going to make this a true equality, make this a true equation that can be solved. Let's look at the opposite scenario. On the other hand, you've got the equation that has an infinite number of solutions. So let me go ahead and simplify this. Gather like terms on either side of the equal sign before you continue on to the next step. So like terms have been gathered on the left-hand side. Looking at the right-hand side, I now have -9x minus 5. Noting that addition commutes, I'm going to go ahead and present it like this and just reverse the order. So you may recognize right now that I have what's known as an identity. When I get the same thing on both sides of the equal sign, that's an identity. And I'm going to keep going. I'm going to try to eliminate the x's. And when I sum the variables out of the problem, what remains are two numbers that are actually equal to each other. So this is a true statement. -5 does equal -5. And if I keep going, if I add +5 to both sides, I end up with 0 equaling 0. Yet again, another true statement. So when the variable sums out of the problem, as it did right here on both sides, when the variable sums out of the problem and the numbers that remain are actually equal to each other, this is a scenario where you have an infinite number of solutions. So the infinity symbol, an infinite number of solutions. There are an infinite number of x values that will maintain this equality and make this a true statement. One more example to do on the video. I would like to look at problem number 3 at the bottom. And then I would ask you to try the others on your own. Well, let's do number 3 together on the video. So here, I'm going to distribute the 8. And distribute the 6. So I've distributed the 8 to both terms. I'm distributing the 6 to both terms. And now I'm going to gather like terms. So let's see, if I add 24x to both sides, I have 64x and -24 equaling -24. So on the next step, I'm going to add 24 to both sides, and I end up with 64x equaling 0. So I'm going to move my work up here just so I can analyze. 64x equaling 0. So now I'm going to multiply both sides by 1 over 64. And I notice that I've got the multiplicative inverses here, leaving me with 1x, or just simply x. 0 times any number is simply 0. So my result is x equaling 0. This is the solution to the problem, And oftentimes when students learn infinite solution and no solution, and then they're solving a problem and the result is x equaling 0, sometimes students are tempted to say that this problem has no solution. This problem's solution is the number 0, so it does have a solution.